In these problems, we are looking for the unknown angle, or angles. Recall from the last lesson that vertical angles are equal in measure. We also see that there are straight angles formed in each of these pictures, and a straight angle adds up to 180 degrees. So you can solve for that missing angle because 95 takes up a part. So what other part needs to be there in order to add up to 180? These also have straight angles in them. Go in here and here. So these two add up to 180. Here the 12 and the x add up to 180, and you can solve for the unknown angles. This is a digital lesson, so if you don't have access to these slides through Great Minds, you can just follow along here and write notes in your workbook. It says move the vertices of the triangle so the sum of the angle measures is as large as possible. So we can drag these around. Maybe we want to make C an obtuse angle. And then if we measure the angles, we see that C is 157, angle B is 15, and angle A is 8. Well, maybe we want to make them all as close to each other as possible, or as close to the same size as possible. So here I have an angle that's 53, 63, and 64, but the sum still comes out to 180. Let's try another. What if we created a right angle? Now I have one that's 90, one that's 58, and one that's 32. What do you notice? I notice the sum of these three attempts all came out to 180, or 180 degrees. I wonder if every triangle has angles with a sum of 180 degrees. Move the vertices and split the rectangle to explore. So maybe we're going to make a really long and narrow rectangle and then click split. Using what you can observe about the rectangle, what do you think the angle measures in the split triangles? Why do you think the angle measures in the split triangles sum to 180 degrees? Well, in a rectangle, 90, 180, 270, 360, and if I split it, what would that be? So in a rectangle, 4 of the angles are 90 degrees. The rectangle has an angle sum of 360. Right, 4 times 9 is 36, so 4 times 90 would be 360. If I split the rectangle into two parts to create triangles, 360 divided by 2 is equal to 180. Let's see if the following equation is true. Are the two angles congruent? How do you know? Yes, these triangles are congruent. They are the same size and the same shape. They could also be mapped to one another using a translation. So are angle 2 and angle 5 congruent? Okay, let's see. In this picture, we're trying to find out if 2 and 5 are congruent. I see 2 parallel lines that are cut by a transversal, or actually let's use this transversal. And you can see now that 2 is to the right of the transversal and below the parallel line, and 5 is to the right of the transversal or above and underneath that parallel line. So we can say 2 and 5 are corresponding angles. Are angle 1 and angle 7 congruent? All right, so here we have 1 and 7. I see a transversal cutting through 2 lines that are parallel. So these would be, they're on opposite sides of the transversal and between the parallel lines, so they are alternate. Inside would be interior. So they also have the same measure. They are alternate interior angles. Is the equation true? The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. All right, well, if we continue this video here, oops, all the way to the end, there we go. We said that the measure of angle 1 is the same as 7. So this angle and this angle match up. We have in here 3, and we also said that angle 2 and angle 5 are the same. So I have a yellow, green, and blue angle in this triangle here. But I also have a yellow, blue, and green in this straight line here. And we know that straight angles make 180 degrees. So by combining these 3, I get 180. But we already said this piece and this piece are the same. So I can swap out this one with measure of angle 1. And we already proved that 5 and 2 are the same, so I can swap it out with these ones. So I have 3 angles that are the same as these 3 angles that add up to 180 degrees. So yes, that equation is true. Because angle 3, 7, and 5 form a line or a straight angle in this section here, their sum is 180. Because angle 7 is the same as this angle here, angle 1, and angle 5 is the same as angle 2, we know the triangle's interior angle measures add up to 180 degrees. Find and mark as many sets of congruent angles as you can. Record how you know that the angles are congruent. So they've shown that 2 and 6 are congruent by corresponding angles. I know that 1 and 3 are congruent because they are vertical angles. We want the symbols here. I'm not seeing it in the little tools, but over here in the shortcuts it says you can create the angle symbol by typing these. So escape, ANGLE, enter. And we have angle 1 is congruent to angle 3. I know 2 and 4 are also congruent by vertical angles. We also see that 3 and 5 are congruent by alternate interior. Five and 7 are congruent because they are vertical angles. Two and 8 are congruent by alternate exterior. We also see 1 and 7 are congruent by alternate exterior. How do you know the measures of 1, or what do you know about the measures of angle 1 and angle 4? They form a straight line, so they are 180 degrees. We've also referred to that straight line forming 180 degrees as a straight angle, or we can say that they are supplementary. So if 1 and 5, those are corresponding angles, so they have congruent or equal measures. So if 1 and 4 form a 180-degree angle, and 1 and 5 are the same or equal, if I swap out this angle 1 with an angle that is equal to it, 5 plus 4 must also equal 180 degrees. What do we know about 5 plus 9 plus 10? You can see right here at the end, there is an angle 11 that shows up. Our job is to figure out the sum of these three angles. But we know that the sum of the angles in the triangle are 180 degrees. 10 and 11, or angle 10 and angle 11, are congruent. And the reason is we have two parallel lines cut by a transversal. So they are alternate interior angles. They're both inside the parallel lines. This one is on the right and this one is on the left. So they are alternate interior angles, which means 10 and 11 are equal in measure. And if these three add up to 180, and we swap out angle 11 with angle 10, then the sum of these three must also be 180 degrees. So what type of angles are angle 10 and 11? They are alternate interior angles, and that tells us they are equal in measure, or they are congruent to one another. So 5 plus 9 plus that little angle 11 that pops up down here is 180 degrees. How do we know? The sum of the angles in a triangle add up to 180. For this one, we get to move the vertices of the triangle around, and we'll click on Measure to measure these angles. Oh, there's a right angle. Let's try that one. I have a 53, a 37, and I made angle C a 90-degree angle, so we can type in 90 here. And the sum pops up to be 180. Let's try some different angles. I have a 65 and a 51. If I add 65 and 51 together, that gives me 116. 180 minus 116 will tell us what that missing angle C is. 10 minus 6 is 4. 7 minus 1 is 6. 1 minus 1 is 0. So 64 should go in that angle C position. Which gives us a sum of 180. Let's try an obtuse angle. I have a 150-degree angle and a 16. 150 plus 16 is 166. So to solve for that missing angle, we'll subtract it from 180. 10 minus 6 is 4. 7 minus 6 is 1. So that missing angle C should say 14 degrees. Which again adds up to 180. Your warm-up should be complete with those missing angles. And then in your workbook, I would include some notes about how the sum of the three angles in a triangle always add up to 180 degrees.